So remember, if I want to work out an unknown side length of a right angle triangle, I have a couple of tools which I could use. For example, let's say I'm given this side length here as 5 and this one here is 7, and I want to work out this unknown side length of a right angle triangle. Well, I could do that by using Pythagoras. Okay, and let's say I'm given a right angle triangle, but this time instead of being given two sides, I'm given one side, so maybe this is 10, and I'm given one angle in here. Okay, and I'm asked to find this side length in here. Well, I can do that by using trigonometry. Okay, in this video, we're going to look at what happens if I'm given a right angle triangle. If I'm given two side lengths, so maybe this is 8 and this is 6, I've got to try and work out what one of these angles is inside of my triangle. Okay, so it's still trigonometry, and it's not going to be too different from the last video, which is good. But we're now looking to try and find an angle instead of an unknown side length. So for example, let's say I am given a right angle triangle, and I am told that this side length here is 12, this side length down here is 5, and I've got to try and work out what this angle theta is here. Okay, well, let's label our sides as the opposite, the adjacent, or the hypotenuse. So I know that this one here, opposite my right angle, is going to be my hypotenuse. I know that the one opposite my angle there is going to be my opposite. And I know that this one here would therefore be my adjacent. So the ones of interest to me are my opposite and my hypotenuse. They're the ones that I'm given. That's my 12 and my 5. So if we have a look at our SOHCAHTOA acronym, we can see the one of these that incorporates the hypotenuse and the opposite is written here. And remember, what does this acronym mean? It says that the sine of theta is equal to my opposite divided by my hypotenuse. Okay, now I can start to put some numbers into this formula. So I don't know what theta is. That's what I'm trying to find. So we'll leave that left-hand side the same. But if we have a look at our right-hand side, I know what the opposite is. I know that the opposite is 5. And I know what my hypotenuse is. I know that my hypotenuse is 12. So I need to try and rearrange this now for theta, which is pretty tricky, and that's not something that we've done yet. So there's a little trick that we have to remember. Now, if I want to get the theta out of this sine function thingy, okay, I have to do sine to the -1 of 5 over 12. Okay, you don't have to worry too much about what this means, okay, but this sine to the -1, we can get that from the calculator. Often, if you're just dealing with a scientific calculator of some sort, you would do shift and then press your sine button, okay? And you should get this bit here pop out. So if you go into your calculator and you write in sine to the -1, so using that shift sign, it should give you that, and you put in 5/12, you should get, coming back out, about 24.6 degrees. So that's what theta is equal to. Theta is equal to 24.6 degrees. So back over here to our right angle triangle, if I erase some of our working out a little bit, sorry, that was a 5. So we'll erase this bit in here. We can see now that if I'm given two side lengths of my right angle triangle as 5 and 12, then this angle in here, it has to be 24.6 degrees. Let's do another example. So let's have a look at this right angle triangle here. Okay, so we've got our right angle there, and we're told that this side length here is 7, this side length here is 9, and I've got to try and work out what that angle theta in there is. So let's have a look at what we've got. We know that this side length here is our hypotenuse, and this side here is our opposite, and this side here is our adjacent. So if we write out our acronym, SOHCAHTOA, we're interested in our adjacent and our hypotenuse. That's where our 7 and 9 is given to us. So the one of interest to us in our acronym is going to be our cosine. Now remember, what does this say? This says that the cosine of theta is equal to my adjacent divided by my hypotenuse. Now, I don't know what my angle is, so I don't know what theta is, so we'll leave that. But I know that the adjacent is 7, and I know that the hypotenuse is 9. Okay, now remember to try and pull this theta out of this cosine function thingy. We can write our theta there, but over to the other side, we have to do our cosine to the -1. Again, we can obtain that in the calculator, often by pressing shift and then the cosine button, 7/9. Okay, and if you put that into a calculator, you should get 38.9 degrees pop back out. So we know that this angle in here is 38.9 degrees. Again, this diagram isn't necessarily to scale. We'll do one more. So we've used sine, we've used cosine. We'll do one more, and hopefully we'll get to use the tangent. So let's say that this is our right-angled triangle here. Okay, and we're told this side length is 4. Up the top is 3, and this side length down here is 4. And we're asked to try and find what this angle theta is here. So let's have a look at what sides we have. We have our opposite up here and our adjacent here. This would be our hypotenuse, but it's not of much interest to us. Remembering our acronym is SOHCAHTOA. So we've got our opposite and our adjacent, so it's definitely going to be our TOA or our tangent, which is going to be of interest to us here. So remember what this says is the tan of theta is equal to my opposite divided by my adjacent. Now I know what my opposite is. I don't know what theta is. That's what I'm trying to find. So we'll leave that bit on the left. But I know what my opposite is. I know that it's 3. And I know that my adjacent there is 4. Now to pull this theta out and get it on its own, I have to do tan -1 of 3/4. Again, we can obtain that in the calculator, often by just pressing shift tan should give you that. And if you put that into a calculator, you should see that theta is 36.9 degrees. So we know that this angle in here is 36.9 degrees.